In this video, we are going to understand stoichiometry using the formula chart shown in the image. At first glance, this formula may look complicated, but once you break it down, it is actually very logical. The entire chart revolves around one main concept, the mole, which is represented by the letter N. The mole is the central link between mass, solution concentration, gas volume, and number of particles. The different equations shown in the image are just different ways of calculating the same thing, which is the number of moles. On the left side of the chart, we start with weight in grams. The formula shows that N equals G divided by mW. Here, G stands for the actual weight of the substance in grams, and mW stands for molecular weight or molar mass. The molecular weight is the sum of the atomic masses of all the atoms in a molecule. Dividing grams by molar mass tells us how many moles we have. For example, if you take 36 grams of water and divide it by the molar mass of water, which is 18 grams per mole, the result is 2 moles. This arrow in the diagram is pointing downward to remind us that grams and molecular weight are directly connected to moles. Next, in the middle of the chart, you see another form of the equation. N equals C times V divided by 1,000. In this case, C represents concentration in mole per liter, and V represents the volume of the solution in milliliters. Since 1 liter equals 1,000 milliliters, the formula divides by 1,000 to make the units consistent. For example, if you have 500 milliliters of a 0.25 molar solution, multiplying 0.25 by 500 and dividing by 1,000 gives 0.125 moles. This is the solution pathway shown in the chart, and the arrow is labeled to remind us that this is based on concentration and volume. The next part of the chart moves to gases. It shows N equals Vi divided by 22.4. This is the formula for gases at standard temperature and pressure, also called STP. Under these conditions, 1 mole of any gas occupies 22.4 liters. That is why the denominator is 22.4. For example, if the gas volume is 44.8 liters, dividing by 22.4 gives 2 moles. This part of the diagram has an arrow labeled gas volume in cubic decimeters, which is just another way of saying liters, because 1 cubic decimeter is equal to 1 liter. On the far right side of the chart, we see N equals N divided by 6.02 times 10 to the power 23. Here, N represents the number of particles, which could be atoms, molecules, or ions. The denominator is Avogadro's number, which tells us how many particles are present in exactly 1 mole. Dividing the number of particles by Avogadro's number converts that count into moles. For example, if you have 3.01 times 10 to the 23 molecules of oxygen, dividing by 6.02 times 10 to the 23 gives 0.5 moles. This is why the arrow in the chart is labeled number of molecules and Avogadro number. If you look carefully, you will notice that all the arrows from left to right are pointing toward the same central value, the mole. The idea is that no matter what information you start with, whether it is grams, solution data, gas volume, or number of molecules, you can always convert it into moles first. Once you know the number of moles, you can then use a balanced chemical equation to find the relationship between different substances and then convert the moles into whatever unit the problem requires. So in summary, this chart is not 4 different equations, but rather 4 different doors that all lead to the same room, the mole. Grams divided by molecular weight leads to moles. Concentration times volume divided by 1,000 leads to moles. Gas volume divided by 22.4 leads to moles. And number of particles divided by Avogadro's number also leads to moles. From there, the mole becomes your stepping stone to solve any stoichiometry problem. This is why stoichiometry is so powerful. It unifies mass, volume, concentration, and particle count under one single concept. If you understand the diagram in the image, you can solve almost any type of calculation in chemistry with confidence. If this explanation helped you understand the diagram completely, then make sure to like this video, share it with your friends, and subscribe to Huzaifa TV Official for more detailed science content. And do leave a comment if you want me to break down more formulas or concepts in this style. Thank you for watching, and I will see you in the next video.